This question was asked for 1 mark. Which one of the following permits the direct determination of intrinsic viscosity of a polymer solution for a known molecular weight of the polymer? And options are Flory-Huggins equation, Newton's law of viscosity, William-Landau-Ferry equation, that is WLF equation, and Mark-Houwink equation. So let's see the significance of each viscosity. But before that, we should know what is the meaning of intrinsic viscosity. So intrinsic viscosity, it represents a hydrodynamic volume or chain expansion of a polymer in a solution. Okay, so this hydrodynamic volume, it depends upon the chain length of polymer. We can obtain this intrinsic viscosity if we extrapolate reduce or inherent viscosity to the zero concentration. Also, experimentally, we can measure this intrinsic viscosity, but theoretically, if we know the molecular weight of polymer, we can calculate the intrinsic viscosity using an empirical relation. Let's see what is that empirical relation. But before that, let's see option one by one. So Flory-Huggins equation, which has significance with the mixing chi parameter, okay, which describe thermodynamic of the polymer solution. So it don't have any relevance with the intrinsic viscosity. Second is Newton's law of viscosity, which describes fluid flow for the Newtonian fluids. So it is shear stress is directly proportional to the velocity gradient. So it also don't have any relevance with the intrinsic viscosity. C is WLF equation, that is William-Landau-Ferry equation, which describe temperature dependence of polymer viscoelastic behavior near the glass transition temperature. Okay, so this WLF equation is related to glass transition temperature and it don't have any relevance with the intrinsic viscosity. D is Mark-Houwink equation, which relates this intrinsic viscosity and molecular weight. Okay, if we know the molecular weight of polymer, we can calculate the intrinsic viscosity. Okay, so it has relevance with the intrinsic viscosity. Let's see what is Mark-Houwink equation. Mark-Houwink equation is this equation, okay, which is intrinsic viscosity equal to K into molecular weight to the power A. K and A are the constant which depends on the polymer and solvent system and temperature. So this equation, it directly links molecular weight and intrinsic viscosity. This Mark-Houwink equation is bridge between molecular weight and intrinsic viscosity. When we already know the polymer molecular weight, the equation, let us predict its intrinsic viscosity directly and vice versa. Okay, these other equations A, B, C, this equation deals with the solution thermodynamics, sample viscous flow or viscoelastic temperature dependence. Okay, not the polymer molecular weight size relationship. Okay, so among the ABCD, this Mark-Houwink equation is the correct, which shows direct determination of intrinsic viscosity from molecular weight of the polymer.